So at least first hour, I only got this far. Not sure how far I'm going to get this afternoon, so you guys will just, at a minimum, um, you might be able to fast forward if I already got farther in the afternoon classes. But first hour for sure, you need to watch this all the way on through. So we got right here, waiting for my pen to activate here. So I had 3 is equal to a plus 5. Remember what my goal was? I was trying to force these two functions, this cubic and this line, to seal at 1. Because if the cubic function goes like this, and then the line takes off and goes that way, I'm going to have a gap. So what I'm doing is I'm trying to force them to meet up at this spot. Now that's actually not that function, but just so you know what I'm doing. So I've got to make sure the y values are exactly the same for both functions at 1. And I'm looking for the slope of the line that'll force that to happen. And I get that to be negative 2. So what that means is that in order for this function to be continuous, my line has to have a slope of negative 2. And if you were to do this graphically, just so you can see the visual, the 3x cubed looks like this, and at 1, I get a 3. And in order for my line to have a y-intercept of 5, right, and hit this point, it's got to be going like this. And I just determined that what will force it to do that is if the slope is negative 2. So the graphical really helps go with the analytical on this one. Now, if it says to use the definition of continuity, that's a 3-part definition that we did at the beginning of the hour and is on one of the first pages of your notes. If I says to validate using the definition of the continuity that this function is continuous at 1, I can see it. I just did it analytically, but here's why it's continuous. There's 3 reasons. Because f of 1 is defined, aka there's a solid dot there, aka that didn't say less than, it said less than or equal to. There's no open hole there. And we can just write f of 1 is defined. Actually, if you wanted to be even more specific, you could say f of 1 equals 3, therefore it's defined. But f of 1, solid dot. The next reason why it's continuous is because the limit as x approaches 1 from the left of f of x, I'm trying to extend my page here, okay, which I just said is 3, is equal to the limit as x approaches 1 from the left of f of x. I forced that to happen. I forced them to meet up there. This is also 3, because remember it's now a negative 2x plus 5 on that bottom piece, and when I put in a 1, it poops out a 3. Furthermore, these two things concur. My dot is where the limit is. How do I write that? I say the limit as x approach 3 from both sides of the function. Sorry, I was approaching 1. Sorry. I have 3's on the brain. The limit as I approach 1 from both sides of the function actually equaled f of 1. They were both 3. So again, the common sense is easy. It's getting things written properly. So the definition of continuity requires you to meet 3 criteria. Again, function must be defined, the limit from the left has to equal the limit from the right, and those two things have to match up. Because if the limit from the left equals the limit from the right, but it's defined down here, I've got a dropout or a discontinuity. All right, so I think while I have your ear, I'm going to keep talking a little bit so I don't have to tomorrow. There are a couple examples. Come on, Paige. On the next page that I kind of want to go through. So we're going to do one more of these, not the recap. I'm going to do this one. So it says the 3-step definition of continuity, and I just discussed that. 1, 2, 3 things to ensure a function is continuous. It says provides us with a system of equations needed to find unknowns. Really what this is saying is I've got a parabola, and then I've got a dot, and then I've got a line. And what I need to make sure is those things all meet up. So the parabola, the dot, and the line need to all be at the same height. Because if not, I've got a discontinuity. So it's pretty easy. Arithmetically, what I do is I make sure they all are the same at -1. So I make sure, that's going in for x, that the parabola at -1 has to equal the dot at -1. So what I'm making sure is this parabola hits up at 4. Otherwise, I'm going to have a dropout. Okay? So I have a minus b has to equal 4. I've got one equation, two unknowns. It means I need another equation. Well, I also know that the line has to take off from 4. So I also know that when I put -1 into the line, it has to arrive at 4. So I've got a -2a plus b is equal to 4. Now from Algebra 1, I've got a system of equations, and I'm going to solve them. I'm going to write this one underneath this one. You might have thought in Algebra 1, when am I ever going to have to solve a system? Here you go. I'm going to add these up. I'm going to get -a. B's are going to go is equal to 8. And so I'm going to get NA is equal to -8. To get the B, I would just go plug that back in. Okay, it ends up being -12. All right, so the last thing we're going to do, this is a very important concept, by the way. There's always a multiple choice question on the AP exam for this, and it's pretty intuitive. Again, you have to make sure for piecewise functions that they seal up at whatever place that fence is. Like if it's at 2, you have to make sure when you stick a 2 into this function, you get the same thing as when you stick a 2 into this function, because if not, you're going to have a jump or a gap. All right, so I'm going to go back to where that formative quiz is. Hopefully I keep this video at a decent, although how bad can it be? You just have to watch me for homework. Come on. It's better than watching Survivor tonight, right? Probably not. So I'm paging back here to the page that has that 5 quiz questions that I'm going to look at for tomorrow. I feel like I'm getting close. Sorry, my page turner doesn't go very fast when the recorder's on because my computer's stressed out with the recorder. So I have to go really slow. Actually, I could outsmart it. Why am I? Just wait a sec. Sorry. Maybe we could pause and go get something to eat, right? Oh, I just went past it. Come on. All right. Right here. So these are what I would call strive for a 5 questions because they're much more difficult, some of them, than what you've had in your homework, but our process won't change. So again, the reason this one's more difficult is because it's approaching A, not approaching like 2 or 3. But the process is the same. I plug A in and I get my equal 0/0. And again, you have to show everything I write to get the 5 points for this. It's 5 out of 5, but it's easy to get those points. What did I do when there's a number there? This is one I use conjugation on. Conjugation of the root. All right, I did that when there are numbers. I'll do it when it's a constant called a. I FOIL the top. Root x is x. Outside and inside cancel for conjugates. That's why we use them. Root a is a. And on the bottom, I'm going to have x minus a times root x. And again, you should be writing this. If you just circle the answers, I'll give you 1 point. Who wants 1 point? I cancel that off, and I get a 1. So I get that the limit, and again, I'm dropping my formal limit notation simply because it's multiple choice, so I don't need it. What am I approaching? Normally, you then go plug in your number for x. Well, I'm approaching a, so I go put an a in for x, and I get 1 over root a plus root a. Please do not tell me that's root 2a or root a squared or anything like that. One of these, it's like x plus x. One of those plus another one of those is 1 over 2 of those. And I don't need to rationalize the denominator. I told you they don't usually do that on the AP exam. You'll notice this is right off an exam. So you'll look at number 2. And I'm approaching 3 from the right-hand side. I plug a 3 in and I get 5 over 0. This tells me I'm going to one of the infinities. Okay, so I'm now at, because there's an infinite amount of zeros in 5, I'm either A or I'm E. To figure it out, I don't go touch my graphing calculator because I won't have it. So I creep, and I creep in from 3 on the right-hand side. So I pick my favorite number to the right of 3. And you could pick 3.00001, but for this particular, you just need to know if it's positive or negative. And you'll notice that when I get to the right of 3, I'd have a negative there. But I want to discuss it like when I get really close. So let's do 5 over 3 minus 3.0001. That would be 5 over negative, right, 0.0001, which is 5 over negative 1, what is it, 10,000th, which is negative 5,000. It's going way, way down. So my answer would be letter A. Now I've got a piecewise going with number 3, so let's take a look at this piecewise. Again, my problem is that when I put a negative 1 into the top, I get 0 over 0. But what that means, again, is I'm going to factor. You might say, well, this is piecewise, but this is saying that everywhere but at negative 1, this is your function up here on the top. So I'm going to factor that. I'm going to cancel. And really, this is a line. F of x is really the line x minus 4. It just has a hole at negative 1, right? Because the negative 1 is what caused the problem. So the question becomes, what is my limit as I approach there? So you got to be very careful with what this is asking you. Again, it's not asking you about continuity or anything like that. It's asking you about the limit there. Well, at negative 1, I'm going to arrive at negative 5. And you might say, well, what's this then? That's a dropout because I know that that was the line x minus 4, which is down here, right? And at negative 1, negative 5, there's a hole. And this is just saying, you know what? You have a dot at negative 1, 2. But the limit is still negative 5. And most kids would pick this. The limit isn't where the dot is. The limit is where you are. So moving down here a little bit more. Let me see if I can extend my page. I'm just going to move this up, actually, I think. Let's see if I can throw some of this out. Stay in my viewing window here. Come on, baby. The next one isn't multiple choice. It actually was, but I think I forgot to screenshot them. So in this one, I'm approaching 2 from the right. Again, I know that my answer is either infinity or negative infinity, because when I stick in the 2, I get 3 over 0, and there's an infinite amount of zeros in 3. So what I really need to do is figure out which infinity is it. Well, I'm approaching 2 from the right-hand side, so I'm going to creep in and use 2.001. Again, that's going to be negative, so I'm going to a negative infinity. You should be good with that kind. The last one here, you might think it's really difficult and you'd be tempted to guess, but again, if I were to guess and I'm seeing all these pi fourths and sines and cosines, I'd probably guess D. But let's go see definitively what it is. And again, a graphical approach is nice. This is saying that to the left of pi fourths, you have the sine wave. That's a parent function. Goes through 0, 0, pi over 2, 1, because the sine, or the y value of pi over 2 is 1, and at pi fourths, it's like root 2 over 2. But it, how could I make this? This kind of goes like that, and here's pi fourths, root 2 over 2 right there. But we are to the left of pi fourths, so I'm going to take that off, and it says strictly less, so I'm going to open that up. That's what this is saying. Then it's saying to the right of pi fourths, you have the cosine wave. Well, the cosine wave starts at 0, 1. At pi halves, cosine is 0, and it kind of comes like this. But those coincide here because sine and cosine at pi fourths is root 2 over 2. So these will actually meet right there. Next, I'm going to get the left-hand part off of here because that was to the right. Okay, then it says at pi force, right here, you're actually the tangent. Well, the tangent of pi over 4 is sine over cosine, which is 1. So you're up here. That's what that looks like graphically. So what was the limit? Where did I arrive when I come in from pi force from the left and pi force at the right? I arrived at root 2 over 2, even though they put the restaurant up at 1. All right, we're done. Hopefully you absorbed that and didn't just copy it. I said it'd be about 10 to 15 minutes, and I'm at 15:38. Booyah!